Alright, so this is day 4 of our notes of Unit 2B. This is one of, I think, my favorite lessons to teach because I think it's pretty cool because we will sketch what functions will look like without touching our calculators. So here we go. We're going to graph each of the following functions based on a few things which we have listed. We'll determine the function zeros, and we'll do that algebraically. We will use their y-intercept, so that's where it crosses the y-axis, which occurs when x is equal to 0. We'll talk about the degree, which will help us then determine end behavior, and then we'll sketch our function. So for A, I'll go in order. For this function f of x, we're going to determine the zeros, and we have to pay attention to multiplicities too, because that's important. That will determine whether there's a kiss or a cross in the graph. So it's already factored for us, which is super nice, because when I set it equal to 0, I can already see that I have zeros, or roots, or solutions at 0, 1, and -1. Okay, so that's where it's going to cross the x-axis. In order to determine the y-intercept, I'm plugging 0 in for x. So all I've done in the function is plug in a 0 everywhere you see an x. Now, you can easily see it's 0 times -1 times 1, so 0 times anything is 0. So we're going to cross the y-axis at 0. Now, the degree. If you were to multiply this entire thing out, it would be x times x, like this would be x squared minus x, and then times another x, you could see that it would be an x cubed. Another way of thinking about that is there's 1, 2, 3 roots, all with multiplicity 1, so that's 3 total. So our degree is 3. Now, as far as end behavior goes, since the degree is 3, it's an odd degreed function, so therefore it's going to have opposite end behavior. Since the leading coefficient's positive, I know it's going to end positively from left to right, so this is going to be our end behavior. Now I'm just going to sketch it for now. At E, we sketch the function. So here we go. I've already put in some axes for myself. If you haven't yet, use a straight edge or a freehand as nice as you can at this point. A nice XY axis. I know I'm going to cross the x-axis at 0, 1, and -1. Let me zoom in here a second. So 0, I'm going to stretch this out a little bit. Let's call that 1, and I'll call this one -1. Okay, so I changed my scale a little bit just to make it nicer, otherwise it's kind of tight in there. I know I'm also crossing the y-axis at 0, so that's also an x-intercept, so it's already listed there. Now, we already know how the end behavior is going to be. I know I'm going to end positively. Since each of these are multiplicities of 1, I know it's going to cross at each of those locations, so cross the x-axis. So at x equals -1, I have to cross. At x equals 0, I have to cross. At x equals 1, I have to cross, and there you go. Now, I know I said I wouldn't touch the calculator to sketch this, and I didn't, but I do want to show you how close I really am to what this looks like based on just knowing the roots and the end behavior. So let me pull up a calculator real quick. Okay, so I've taken a second, I've taken my online simulating calculator, and I've plugged in the function x times x minus 1 times x plus 1, just as you see it, and I should end up with a graph that looks pretty similar to what I sketched. So I'm just going to do a zoom 6 for my standard window. Zoom 6 is your quick fix. And there you go. Pretty good. Okay, so now I've moved on to the second example in our notes. So again, it's in factored form, so I already can just look down the line and tell you my roots. I've got 1, 2, and -4 with a multiplicity of 2 because it's occurring twice. My y-intercept is when I evaluate the function at 0, because then x equals 0, that's when you'd end up somewhere on the y-axis. So this would be just plugging in. Okay, so this is -1 times -2 times 4 times 4. So that's 16 times a positive 2, so this goes to 32. So we're going to cross the y-axis at 32. So I'm going to have to adjust my scale. Keep that in mind. What's next here? What did I want next? Next I want degree. Okay, so again, the degree is equal to the highest power you would see if you were to multiply this out, or even counting up these multiplicities. There's 4, or 4 roots, so this is a degree 4. Since the leading coefficient is positive, it's going to be up in both directions, and now we're free to start sketching. Alright, so I know I'm going to cross the x-axis at 3 places, or touch the x-axis I should say, at 1. Actually, I'm going to adjust this a little bit. Let's make this 2 boxes is 1. 1, 2, and negative 4. So all the way over there at negative 4. Okay, so 0 here, 0 here, 0 here. And I adjusted my scale just to make my graph nice and spread out. Additionally, I know I'm going to cross the y-axis at 32, so let's just say, I'll zoom in here a second. Let's just say that I'm going to go by 8s. Make sure you label if you adjust your scale too, guys. So 8, so that means up here would be 32. Make it nice and clean. Okay, so I'm going to cross the y-axis at 32. Now, I already know my end behavior. I'm going to end up like that. Now, what happens in between at each of these zeros depends upon the multiplicities. Now, anytime it's an odd multiplicity, that's a cross. So I'm going to cross at 1. I'm going to cross at 2. Since there's a multiplicity of 2 at x equals negative 4, that's going to be a kiss. Okay, so here we go. So this has to be a kiss, so that means I'm going to come back up. Oopsies. Not touching the x-axis again for a while. I'm actually going to cross the y-axis at 32, come back down and hit the x-axis at 1 because I have to. Okay, there's a cross at x equals 1, so I'm going to cross the x-axis. And then when I come back to 2, there's going to be a cross, and there you go. That's our graph. And if I plugged it in the calculator, I bet it would have a very similar shape. Alright, so now we come to example 3. When you look at our function, you can see that it is not factored for us, so we have to do a little bit of work to figure out our zeros. So, this is where our skills from Unit 2A are extremely important. Factoring in general is extremely important in this course. Since there are 4 terms, I'm thinking this is a factor by grouping. So I can factor out a x squared from the first 2 terms. And I can factor out a negative 1 from the next 2 terms. There's my common binomial of x minus 2. And x squared minus 1 is a dots problem. And there you go. So by factoring it, I can now set it equal to 0 and see I have roots at negative 1, 1, and 2. Since each of those are a multiplicity of 1, I know they're going to be crosses in the graph. So crosses at the x-axis. Alright, next I want the y-intercept. It's actually easier to go back to the original function before it's factored to determine the y-intercept. Because if you look at it, it's 0 cubed minus 2 times another 0 minus another 0 plus 2. So it's pretty easy to see that your y-intercept will be 2. So yeah, it's actually easier in its unfactored form to determine that. It's just that last number. Okay, next, degree. You can already tell because of its unfactored form that the degree is 3, which means it has opposite end behavior. And since our leading coefficient is positive, I know it's going to end positively. Okay, so now I have everything I need to get going. So I'm going to do, again on my x-axis, every 2 boxes is 1. Okay, so now I'm going to cross at negative 1, 1, and 2. Don't forget we also have to cross the y-axis at 2. So I chose to go on my scale as every 2 boxes is 1 on the y's as well. So y equals 2, I know I'm going to cross the y-axis. Okay, I already know how it's going to end. And from there, I just have to fill in the middle stuff. I know I have to cross at -1 because there's a multiplicity of 1. It's odd. Hit the y-axis at 2. Come back down, cross the x-axis at 1. Come back up and cross the x-axis at 2. And there you go. So what I just modeled for you guys is exactly what I'd expect you to do without a calculator on your quiz that's coming up. So yeah, be prepared for that. All right, coming on down. Last example of our notes of today. This is already factored for me. I'll write it out in an expanded form too so that you can see what I'm looking at. This is x minus 1, x minus 1. Okay, so if I solve for my roots, you'll see that I have 0, 1, and 1. So keep in mind that's x equals 1 with a multiplicity of 2. The negative in front will be important for my end behavior, so don't forget about that. I'm going to put some axes on my graph too. I forgot to do that before I started. All right, now what was next? Y-intercept. If I plug 0 in for x, and I did this in its factored form, actually, I don't even care what the rest of this goes to, even though it's -1 and 1. I know I'm going to be eventually multiplying by 0. So my y-intercept is at 0 again. C is my degree. So if you were to multiply this all out, it would be a degree 3, which also, if you count up your multiplicities, that's 2 plus 1, which is 3, which means it has opposite end behavior. Now, unlike the other ones where it ended positively, remember our leading coefficient is negative. So that means I'm going to end negatively. Okay, and now we're good to go to start graphing. So I have to cross at 0, 1, and, well, actually just 1, so just 0 and 1. Notice how anytime I change the scale, guys, I am labeling. I can't assume that somebody will know that 2 boxes is 1. I have to make sure I label that. I know how it ends. Just like that. Since there was a multiplicity of 1 at 0, that means there's going to be a kiss on the x-axis. Or excuse me, that's not going to be a kiss. It's going to be a cross. Sorry, a cross at x equals 0. And then since there's a multiplicity of 2 at x equals 1, there's going to be a kiss. So, based on how this works, I have to cross here, come back up and touch the x-axis at 0, and then since there's a kiss, it's just going to touch it and continue in its downward pattern. Let me just do a graphic check just to show you. Okay, so again, you won't have your calculator on your quiz, but I do want to just show you that I am doing a pretty decent job. Let's see, so I plug this in. When I hit graph, I should get a graph that looks just like what I sketched. And it's pretty good. Let me see if I can zoom in here. Just to see how good I got it. There you go. You can see I crossed at 0, kissed at 1, and continued. So my sketch is pretty good. I don't necessarily know how far deep I go here. I'm just guessing. But if I'm sketching the general shape of this graph, I did a pretty good job. And that's your notes for today. So what I've modeled, we will do again tomorrow. And this is a lot like what your quiz will look like as far as your non-calculator section of the quiz coming up. All right.